continue with problem 55. So, what do we have in problem 55? In problem 55, we have to prove that the volume of an hemisphere with radius r, to prove that this is equal with 2 pi r to the third over 3, and that, the way of proving it is to prove that this here is equal with the volume of a cylinder with radius r and height r when we subtract a cone, a circular cone with radius r and height r. So this is the figure here. So you have the cylinder in the blue and you have the cone. So we have to prove that whatever is left is equal with this here, which is equal with this here. So, first of all, why this here is true? We know that the volume of a cone with height h, the volume of a circular cone with height h and radius r is given by this formula here, pi r square h over 3, and the volume of a circular cylinder with radius of the base r and height h is given by this formula, pi r square h. So that means that if this here is correct, that means that when you subtract, when you subtract the two volumes, the volume of the cylinder minus the volume of the cone, that should give you the volume of what is left, which is supposed to be equal with this. So let's see how much is this. So we said that the volume of this cylinder is given by this formula, but also the h here, the height is r. So that means that the volume of this cylinder, the blue cylinder, is pi r to the third. And now the volume of the cone that we subtract is pi r squared. The height is h again, so it's equal with pi r to the third over 3. So if you put everything under the same common denominator, 3 pi r to the cube minus pi r to the cube, so that's equal with 2 pi r to the cube over 3. So that's where this comes from, but we have to prove it using calculus and in particular this washer method. And this is nice because one comes to appreciate mathematics. This is an application of mathematics, and let's see how we can do it. It's relatively easy. So let's assume that we put this cylinder on the x and y axis in such a way that this would be the x-axis and this would be the y-axis. So that means that the let's say the end of the cone, it's exactly on the origin of our Cartesian system. So, and now it's pretty obvious. I think that what you have to do is you have to, in order to find what we are looking, which is what is left, one would subtract from the whole thing the red cone. It's the volume which is rotated, the volume which is created when we rotate this area here, around the y-axis. So that means you have to rotate first the r around this here, around the y-axis, and then you have to rotate the red line around to the y-axis and subtract it. So that means it's pi, and